The title of my project is Beyond the Shadow of a Doubt, and it falls under the mechanics section of physics sciences. Have you ever been on a road trip with your family when your car ran out of gas and you had to stop at a gas station? Have you ever wondered if there's a more efficient way to run vehicles and machinery? Solar power aims to be just that by harnessing the natural energy from the sun. Passive solar power is the non-mechanic use of the sun's energy, such as for light and heat. Active solar power works by creating solar cells, which mix silicon and boron to create atoms that have an odd electron out. Then the lens of the solar cell focuses photons from the sun onto the odd electron, causing them to bounce off their atom. This bouncing off creates the energy. My problem was, does the angle of the sun affect the performance of a small solar-powered toy vehicle? My hypothesis was that the angle would affect the performance of the solar cars, and that at their fastest times would be at noon, since then the angle of the sun is the most direct. However, I hypothesized that they would both be slow. The variable in my experiment was the time of day and thus the angle of the sun. The constants for my experiment were the cars we used, the length of the track on each day, and the day on which we gathered the results. There was no control group in my experiment. To start the procedure, we purchased both the vehicles, the OUI Super Solar Race Car and the OUI Aerial Cable Car. Then we purchased the other supplies, such as several 2.44 meter long wood planks and 7.34 meters of garage door weather stripping. To set up the track for the race car, we nailed the weather stripping to several of the lengthwise wooden planks. To make the track for the aerial cable car, we tied its guide string between our garage and our swing set. On day 1, we performed a trial at each hour between 11 o'clock a.m. and 2 o'clock p.m. Each time we ran both the cars 5 times, averaged their times up to get our results. On day 2, we changed the experiment slightly. We marked off the race car track at 2.44 meters and 4.88 meters. We ran each of these lengths 5 times at each trial and averaged their time separately to get our results. Table A shows the results for chart A and chart B. The sun's angle climbs till 1 o'clock p.m. before going back down. Chart B shows about the same thing. At 11 o'clock it climbs till 12 o'clock before stabilizing out. However, the Olympic average at 11 o'clock, this here, is inaccurate. Table B shows the information on chart C and chart D. Generally, they climb till about 12 p.m. to 1 o'clock p.m. before going back down. However, 11 o'clock a.m. on chart C results were obstructed by clouds and thus are not accurate. My conclusion is that the angle of the sun does have a positive effect on the performance of the solar cars, and they reach their height between 12 o'clock noon and 1 o'clock p.m. However, my hypothesis that both the cars would go very slowly was mostly proven wrong. The race car went very fast. The cable car went slower, but that was mostly because its machinery was more complex. However, clouds and other forces of nature have great influences on the performance of solar cars, as seen at 11 o'clock on chart C. To conclude, solar power is an up-and-coming new research that, when it is perfected, we and our descendants will enjoy in the future. Any questions?
Yeah. Can you explain what exactly you have graphed? I mean, what the x and the y axes of your graphs are?
Okay. The blue bars on the graph show the angle of the sun at each hour, and the lines show the average, the Olympic average, and the median.
What is the Olympic average?
It's the average of it's when you take the fastest result out and the slowest result out and average the three in between.
Okay, and you said that you changed your experiment on the second day with the lengths of the tracks. Can you explain why you did that?
The results on the full 7.34 meter track with the race car were kind of inconclusive because the car kept like jumping the track and running into the walls and such. So we thought there would be a much smaller margin of error if we shortened the track.
Okay. Thank you.